Ever wondered how your email service knows which email to flag as spam, or how medical professionals predict the likelihood of a certain disease? The answer often lies in a machine learning technique known as logistic regression. Logistic regression, despite its name, is not a regression model, it's a classification model. In the world of machine learning, this means logistic regression is used to predict the probability of a categorical dependent variable. Imagine a world where everything is either black or white, spam or not spam, disease or no disease. That binary outcome is what logistic regression predicts. But what if they are more than two categories? Fear not, logistic regression handles that too with something called as multinomial logistic regression. Now let's dive into the heart of logistic regression, the logit function. This function is the natural algorithm of the odds that the particular event or outcome will occur. The logit function translates a binary outcome into a continuous input which gives us the probability of the event occurring. The equation for logistic regression is simple but powerful. The dependent variable is the logit of the probability of the event, and the right side of the equation is a linear combination of independent variables. These independent variables can be anything from age, income, education level, and so. The assumptions of logistic regression is that the independent variables are not highly correlated with each other. This condition, known as multicollinearity, can inflate the standard errors of the coefficient and make the estimate very sensitive to minor changes in the model. Also, logistic regression also assumes that the relation between the logit of the response variable and the predictor is linear. This assumption, like all other assumptions in statistics, needs to be checked before applying the model. So where might one encounter logistic regression in the wild? It's used in a wide array of fields, from healthcare to finance to marketing. In the healthcare, logistic regression might predict the likelihood of a patient getting a disease based on various factors. In finance, it could predict whether a customer will default on a loan. In marketing, it would predict whether a customer will make a purchase. In the essence, logistic regression is a powerful, versatile tool in the world of ML. It translates complex relationship into a simple probability, allowing us to make predictions about the world around us. So next time you see your email service correctly flagging a spam email or a medical professional accurately predicting a disease, you will know that there is a good chance logistic regression is working behind the scenes. In a world filled with data, understanding logistic regression is more than just understanding a ML technique. It's about understanding the way we predict and navigate the complexities of the world, and that's the power of logistic regression.